Welcome to my session. I'm excited to be here. First time in India for me. We have given a training session yesterday where we have been talking a little bit about this topic as well. This talk is slightly different, but it will reuse some of the content from yesterday as well. All right, so Postgres parameter tuning is a topic that is as old as Postgres, I would say. So we are talking about a topic that has been explored for about 40 years. And today we will try to see if it's possible to move from a manual tuning of Postgres parameters to an auto-tuning approach. Just a little bit about myself. I have a computer engineering background, did my PhD in applied mathematics and computer science from University in Paris, worked as an engineer for a few years, and then did postdoc research at Imperial College London and Stanford University in California. Became an assistant professor in machine learning in 2019 and founded DBTune in 2021. All right, just a little teaser. DBTune is an AI-powered database parameter tuning service. This is an output of research at Stanford University, where we were studying research on how to use machine learning to optimize computer systems. After many years doing this type of research, we decided to focus on one specific topic, and that's where we started focusing on Postgres and parameter tuning in Postgres. This is the solution that observes, iterates, and adapts until converging to a suitable solution for parameter tuning. Okay? And it's all based on a learning algorithm. This is the outline for the talk. We'll give a quick introduction of the team first, and then talk a little bit about the global challenges that we are seeing in the world today, and then dig into the definition of database tuning, and specifically parameter tuning. We'll propose a solution based on machine learning, and we will look at some interesting results. If I will have time, I will also give a demo. We'll see how it goes. All right, so this is the team. You can perhaps recognize some of the people that have been speaking at this type of events for a very long time. Very proud of being a colleague of Magnus Agander, for example, with Postgres core team, and having as an advisor Peter as co-founder and CTO of Percona, as well as Johan Svensson, who is co-founder and CTO of Neo4j. For the rest, we are a team composed by machine learning engineers, front-end developers, back-end, software engineering, and we work together for implementing this AI-powered solution to this 40-year-old problem. But before starting that discussion of the technical part, just wanted to briefly mention what type of pressures we are feeling these days in the world, right? So inflation is crazy, economic downturn. There is a lot of customer expectation going on right now, and security breaches. There is an explosion of automation, especially through the lens of AI. And sustainability is becoming an extremely important topic, explicitly because of the younger generations that are really pushing this forward. And the impact on enterprise and perhaps the resolutions that the enterprises have to respond to those challenges is to seek for higher operational efficiency and cost reduction. The adoption of open source, which was considered somewhat strange 15 years ago, became commonplace. And the embracing automation or shifting left all sorts of activities through AI and machine learning, and the reduction of carbon footprint. Those are top priority for enterprises these days. And when I see that long list, I don't see problems. I see opportunities. Okay, so one opportunity, for example, is to, looking at some of the statistics on infrastructure cost optimization, you can see, for example, that 35% of all cloud spend is wasted. So that's roughly a third of what we use is actually just not used, actually, right? And the department or cross-department activity that started a few years ago called FinOps or Financial DevOps is this activity of really trying to scan your computing infrastructure and finding efficiency to basically reduce that cost. you can see some of these large companies, most of the cost of revenue is really spent on infrastructure costs. Here we're talking about more than 50% of the cost sometimes. So very, very large. The second big opportunity is in terms of sustainability and green computing. So green computing, you may have heard this term quite for a few years now, but until 2024, we have not seen this really shaping up the scene, right? But in Europe especially, things are moving forward. So for example, there are some directives, like for example, the CSRD for general companies that have above 250 employees. They will have to report their CO2 consumption of 2024 in 2025. That means that in 2025, every company, every enterprise company above 250 employees, they will have to report CO2 emissions, right? And so this is a first phase where the EU is asking for basically monitoring the CO2. There is no constraint on how much CO2 you can use as a company today. But this is just the first step to get into a second step a few years from now, which will be, now let's bound the CO2, the tons of CO2 that you can actually use. And this is very relevant as well in terms of data centers, and especially because data centers are also seeing those type of directives applied to them explicitly. So this is for now just a suggestion and a monitoring. It can affect large enterprises if you show that you're using a lot of CO2, for example, because maybe young generation Z will not want to come to work for you, for example, in terms of appealing of the brand. But in the future, there will be much more constraints, and this will be an actual issue if you're using more than what you can. And when I say issue, I mean money, basically, right? But how can we connect this kind of enterprise priorities with what we do, which is running databases and trying to make database go fast, right? And in my head, there is a very explicit connection between those two objectives and running databases. And I would like to try to make the point very clear in this presentation. So first of all, let's define what database tuning is. So database tuning is the practice of keeping the database fit and responsive. Okay, so databases are dynamic objects. They change, they grow, and slow down over time. And not all workloads are the same. Machines are different. So if you look at AWS or Azure, you have a long list of different machines that you can use, and workloads are also very different depending on the application that you have. So the process of tuning is the process of adapting a database to its current use case, load, and machine, right? So it's specifically doing something on the database that will make it comfortable on that specific server for that specific workload. It's customizing this process to your specific use case. And it's usually considered a little bit of a dark art, meaning that it's a DBA job. Now, these days, developers focus on that as well. But it's a lot of trial and error, and it's a tedious process. I will show the complexity of this in a minute. And there are several departments in tuning, right? So there is query tuning. You may be familiar with changing the queries in a way that they're more efficient to run. There is database management system parameter tuning, which basically means optimizing your memory hierarchy. That's how I will frame it. Or in other words, making sure that the disk, the RAM, and the CPU work well together. Index tuning, operating system parameter tuning, and so on. So there are several parts of this. And the database administrator usually focuses on all these parts. Today we will be focusing on database management system parameter tuning. So the second of these elements here. So why does this matter? Okay, so from a technical perspective, this is pretty obvious, right? So we are, improving the system performance. In general, we measure this in terms of throughput or transactions per second, or in terms of latency, measured usually in Postgres as an average query runtime, or P95 latency, P99, depending on what you're looking for. This also improves scalability, enhances stability, reliability, and SLAs, right? There is a business perspective as well. When we have our databases that are run efficiently, we also decrease cloud and infrastructure spend, and I will double click on that in a minute. We end up having higher end user satisfaction, so your users will not wait for a long time before the web page loads, for example, with the results, right? There is a reduced downtime, there is an increased productivity, increases operational efficiency, and saves energy as well. So I will double click on the saving energy aspect as well. Let's go a little more in the technical details of what this means, parameter tuning. So the process of parameter tuning is, and by the way, parameters have different names in Postgres. They're sometimes also called knobs, just to give it a general name. And the process is like the picture that you see here on the slide. So you have all these different parameters, and now you're being, kind of a DJ or something. You're playing with these knobs and trying to find the best, configuration of this board here. So it doesn't seem very difficult, right? You just have to find the right combination of these parameters in a way that your performance goes up. Now, I'm assuming that if you're here, perhaps you've seen some of these names before. If you didn't, I will just introduce them here in this slide so that we align on what those are. Workmem, shared buffers, maximum size, those are the type of parameters that usually we tune in parameter tuning. And just to give an example here, workmem, for example, is the parameter which basically allocates a little buffer, little cache, which is related to one query. And so if the query internally is doing some calculations, like for example, some sorting, then this local memory will be used as a cache so that you don't spill back on disk, right? Reducing the amount of times that you spill on disk will increase the speed of your application. Well, similarly, shared buffers is another piece of buffer which focuses on something slightly different. And shared buffer will focus on creating a copy of your table content and index as well. And putting it in this buffer will allow you to have the data locally available. So it's about exploiting local temporal and spatial locality, right? So this is the technical term used. So having the data locally will allow you to not go back on disk and fetch it. And you will save a lot of time by not doing that. Now, the problem seems pretty simple. You just have to find this parameter value which gives you high performance. Can I just try it all or something? Can you just give me one that works, what configuration for this that works across the board? Well, unfortunately, the answer is no. Because these parameters will affect your application, but they're also application dependent. And so it means that if you give me an application, the solution for that application will be different from the solution that my friend on the side will use for his application or her application, right? So if we look at the blogs online, you will find a lot of content that really tells you what you should learn if you want to do parameter tuning, right? So you can go read them all, and you will learn how to do this. Perhaps you need to spend a little bit of time. It's a lot of work. But what you will find, for example, in these blogs is that workmem and shared buffers, which I just introduced in the previous slide, they're parameters that are very, very important to be tuned. Okay, so all those blogs will tell you if you have workmem and shared buffers, you need to take care of them because they have a big impact on your application. So if I was doing this for the first time, I don't know. I mean, I will probably just try a lot of combinations of these two parameters. Now, I was plotting this performance response surface with respect to workmem and shared buffers for a benchmark that you can download from the internet called Benchbase, and Resource Stressor is the name of the benchmark. And here in this plot, I'm showing all the possible combinations of these two parameters here. And on the y-axis, I'm showing the throughput in transactions per second. And as you can see in this plot, shared buffers is important because if you're around here, you get better performance, right? So here, higher the better. Throughput wants to go up, right? But in terms of workmem, you can see that workmem doesn't really affect, well, I would say at all, your performance. So in this case, if I was doing this manually, I would have spent a lot of time trying to explore workmem, but at the end of the day, I would have realized that workmem doesn't matter. The only one that matters here is shared buffers, right? So here, perhaps I'm just trying to show that even on 2 parameters, just to figure out which one I have to configure, it's something that needs a lot of trial and error. Now, if we look at how many parameters are available in Postgres, there is a linear trend ongoing, right? So if you look at the last, 20 years or so, you see the number of parameters is increasing linearly. We have about 300 or so parameters these days. Now, in Postgres 16, I meant. Now, not all these parameters are important. In practice, I would say that fewer than 20 are actually really important, right? So, however, if you just look at the complexity for just 12 parameters, you will see that this is an exponential, combinatorial problem, meaning that as soon as you add 1 parameter, the complexity goes up not linearly in the same way the number of parameters is going up, but exponentially, okay? So if you look at 12 parameters, for example, you can see that this already gives you roughly 1 trillion possible configurations, okay? 1 trillion possible configurations. Now, if you consider 13 parameters, just 1 more, you already go on the 10 trillion possible configurations, right? 1 more parameter, 14, you will go to 100 trillion possible configurations. The number is growing exponentially, very quickly. Now, I'm usually really bad at, I was saying that yesterday, I'm really bad at imagining how big 1 trillion really is. So I create these images in my head. I like the moon, so I like to refer to the moon. So if you take a $1 bill and you stack it 1 trillion times, you roughly get halfway to the moon. Okay, so now the problem we are trying to solve here is to find, perhaps the $1 bill in this huge stack that gives you the best performance of the system. Now, we're not really interested in finding just the $1 bill, because perhaps there are a bunch of $1 bills that roughly perform the same, so you can find one of those. But you're still considering a very large space, and you're trying to focus on finding something really niche, right? All right, so how is parameter tuning tackled today by database administrators and developers? So this is kind of what people do today, manual tuning. So, and this, there is my colleague, Magnus Hagan there, who is my tuning guru that does this for a living. He's been doing this for 20 years. And, it's a little slow because you need to sit down in front of your screen, try a bunch of different options, and the process can take several hours, sometimes even several days. I've heard people telling me even several weeks, okay? And it's painstaking, you need a lot of expertise. So if you're a beginner, it's a little challenging to optimize maybe 12 to 20 parameters because of the reasons I was describing before. It's also ineffective because applications are quite dynamic and you sometimes change your queries, you change your application. And if you do that, you need to retune again, right? And it's also inadequate in the sense that there are usually multiple workloads that are running on one machine. You have your daytime workload, nighttime workload, you have your reporting weekend workload, you have Thanksgiving workloads, right? So these workloads can be wildly different. An alternative solution, a second category, is what we call heuristics or rule-based approaches, right? And here I'm talking for the ones that have seen this before about PGTune or the Postgres configurator, for example. So what they do is to basically get some sort of like machine model. Machine model is basically how much RAM do you have, what kind of disk you have, how many cores you have in your CPU. And then they basically give you this, they spit out this configuration file, a PGConf, that you put in your confd, and you're basically done. It's amazing, right? So you push a button, they give you this file, you copy paste it, and it's done. So that's very convenient. However, these solutions are not really bespoke to the application. And so it's usually a solution that doesn't really reflect what you are doing, okay? And by the way, in this category, there will be also the category of the various RDS. So if you're, or flexible server, for example. So if you're buying one of those services as a database as a service, then you will be provided a configuration of the system which is related to the size of the machine, and that falls in specifically in this heuristics-based category, okay? This suffers the same issues as Magnus. It is the fact that this is a little ineffective if you need to do it again and again, and inadequate in the sense that this may change over time. So the holy grail of tuning is this third category. And this third category, what it says is that it would be really cool if we can, instead of trying to guess what's going on, how about if we just observe what's going on and try to learn some sort of model that will tell me then how to act on this configuration, right? And this solution then is based on autotuning. Autotuning is a term that has been around for a fairly long time as well, automatically tuning, right? And it's a solution that adapts to changing workloads. And here, ta-da, well, this is what we are trying to do with DBTune, right? So just to maybe put this in the context of what's going on today. So the question on how often do you tune, it's very often answered like once or twice a year, right? But the problem is that very often, and perhaps I should focus on this other slide first. So this reactive versus proactive approach, right? So people very often don't tune their instances until things go really, really badly, and then they have to step in and fix it, right? So today we have a reactive approach. So we wait until things go badly before doing it. But if we had something that can auto-tune itself, then perhaps we can have a more proactive approach. So instead of waiting until the performance goes down, hits the floor, and then you bring it up by having massive work, you can just bring it up every time it goes down. So things become more proactive. This is a problem that today is basically looked upon like once or twice a year, and by having a proactive approach, you can affect that, and often engage expensive external resources, experts, and different workloads are not treated differently. I was talking about that a minute ago. And the modus operandi, or modus operandi, if you prefer, is to throw more hardware to the problem. So you basically have a problem. You just double the size of the machine, and you solve the problem. Now you have created another problem on the side, which is that you're spending basically double your infrastructure spend. So the question on how often do you tune is often related to your application, how often your application changes, how often your query change, the growth of the database, how frequently your database grows substantially. It's not uncommon to have an alpha terabyte per every 6 months, for example, growing, and whatever you're migrating from on-prem to cloud, those are all triggers for tuning. If you're scaling your instance up and down, this is also something that you may want to do. If you're moving from Oracle to Postgres, you will certainly need some certain amount of tuning. And also if you're upgrading Postgres, this happens, I mean, if you're a good Postgres user, perhaps every year. So every year, the fundamental piece of software you're using is also changing, so you probably want to retune again in that setting. All right, so here is what we are trying to do at DBTune, right? So this is a machine learning-driven approach. It's dynamic in the sense that it takes into account the workload that you have, your application specifically. It's easy to use because it doesn't require any background on artificial intelligence. It doesn't require any background on parameter tuning either, right? Of course, if you're a database administrator and you're very curious, you will probably want to see what's going on, and we give you a nice interface to see that. But in practice, this is a fully autonomous system that does it automatically. It's also highly scalable because it's based on a SaaS model. And these are the 4 things that DBTune does for you. First of all, it reduces your cloud cost. It makes your service radically faster, and you will be surprised by how many people that are still using Postgres on the very default Postgres configuration, which is extremely bad. It's bad for a good reason, because Postgres runs on many different machines. Sometimes they're very small, right? Sometimes they're very big. And so the parameter configuration needs to be very conservative, because otherwise you will end up installing your Postgres, running your application, and the system will crash right away. So the configuration of Postgres needs to be a little conservative in that sense. And so if you start from the baseline of default Postgres, you can achieve easily a 15x improvement, and that's a massive improvement, right? But this usually also improves over manual tuning. So if you manual tuning your system, you usually manage to get a little more performance squeeze out of that server machine if you use this type of solutions. It also frees up your database administrator time. Here, database administrators are extremely busy running databases. They have 25 tasks on their plate. And this is one very narrow task, which is challenging and time-consuming, and we're trying to automate this one task. It also helps you to reduce energy consumption. We will talk a little bit about that in one slide in a minute. But let's look at how it works. So this is the high-level view. OK, so here on the left, there's a lot to take in here, but let's go through. This is on the left, your database instance. This is an open source DBTune controller or AI agent, if you want to call it like that, that contains two submodules, an actuator and a monitor. Okay? And on this side, you have the machine learning optimizer, which is currently running on AWS. I mean, that's not very important. But there is the internet here in the middle. Okay? So the optimizer will recommend a configuration of the system. The actuator will actuate this configuration. The database instance will run for a while. And then the monitor will collect all this data, telemetrics data. We're talking about CPU usage, memory usage, throughput latency, disk usage as well. And then we'll return this telemetrics back to the optimizer. And the optimizer now will learn based on what was observed. And we'll build some models that will help the process to be kind of better over time, right? So you learn some models which will tell you where the good performance is, and so will guide this optimization, right? So this is an online machine learning system that, in an online fashion, will observe, change, observe, change. Well, there is a thinking process as well in the middle. So it will observe, think, change, right? And to be clear, so this is an open source controller, so you can read what that does. You can actually read the Python code. So if you're fluent in Python, you can read it in probably 20 minutes. And the monitor is only checking data which is not in the tables. So we're not looking at data that is private. We're only looking at data which is related to the machine and the performance, okay? Which usually simplifies the process with InfoSec departments, right? All right, so this is the high-level view. If you were to use this, you will need to install this piece of open source and make it connect to your database instance, and then everything else will pretty much happen out of the box. If you're concerned about connecting to the connecting to the internet, we provide a solution that is a package that we ship, and you install it on your virtual private network or your data center, whatever, and it will work in a non-SaaS model. So for large companies, this may be actually an interesting deployment mode. And if you're using things like AWS or flexible server, there is another way of deploying this, which is through permissions, cross-account permissions. So you actually don't need to install anything really here. And you just give permissions, and then through APIs, the optimization engine is able to access the parameter space to be optimized. All right. Let's go into the performance analysis now. So here I'm showing time on the x-axis, and I'm showing performance in terms of transactions per second on the y-axis. And I'm running on RDS M5 2x large. I'm running this benchmark, which is pretty famous, TPCC industry standard. And what I'm showing here is that if you, as I was saying before, the heuristic basic category, the second category I was mentioning before, gives you this solution to this problem. RDS gives you the solution. So I use that solution here, which is the one that you have once that you buy M5 2x large and running Postgres there. You will get this solution here, which is 850 transactions per second. And it's in red there. It's all flat because it doesn't really change with respect to the workload that you're using. In this case, TPCC. Now, if I play around and I double the size of this instance, I go and use the 4x large, basically double the size, double the hardware. I get double the performance, right? So that's great. So I double the instance, double the hardware, get double the performance. So this doesn't happen all the time. You cannot always double the hardware and get double the performance. Well, this is happening here. All great. So this is the PGTune solution. If you're familiar with PGTune, I'm assuming that some of you here may have used this before. PGTune is open source, free to use. You use it here. You get this little bump in performance as well, which is great. Now, DBTune works in a fundamentally different way. So these 3 lines are part of the second category, and DBTune is part of the third category, which is a new category based on observation and learning, right? And so what happens here is that DBTune will start, observe, and change the configurations a number of times that is represented here by the number of tuning iterations, and eventually will converge into a high-performing area here. Now, please notice that this is running on the small instance, the M5 2x large. So DBTune is running on the small instance, but is achieving the same performance as the large instance, right? And it does it through iterations. In the same way, a manual tuner, my friend Magnus, for example, will do it manually. Will sit down, try once, try a second time, try a third time. But the beauty of this is that he's able to do it in a relatively small amount of time. This whole process takes about 2 to 3 hours in total, okay? So very, very fast. And what this plot says is that DBTune on the smaller instance is able to achieve a level of performance in excess of that achieved by an instance twice the size, which is quite interesting, right? If you look at the economics of this, you look at the hardware, and you see that the hardware is all double, the small instance versus the large instance, double cores, double RAM, double IOPS. If you look at the cost of the instance on AWS, you get these numbers. If you look at the cost of the disk, you look, these are the numbers. If you add these 2 numbers, this is the cost of the instance per year. That's the big one, and that's the small one, right? So what this previous slide is saying is that you're basically saving $8,000 per year in terms of just one instance. Now, if you look at how many instances people have out there, this can very quickly go up, because companies have tens, large enterprise customers have tens, if not hundreds, or even sometimes thousands of these instances running in parallel. There is a little article by Andresin and Horowitz that talks about this, the cost of cloud. That's a pretty interesting blog post if you want to read it. All right, so this was for the performance and FinOps. I talk about performance. I talk about financial DevOps, so cost of cloud. Now we'll spend a minute on the CO2 consumption as well. And based on these calculations that we were doing before, based on the fact that you can run on a smaller instance, now you're also saving roughly 50% of your CO2 emissions, which if you look at the data center level, it's going to be a 32% roughly out back of the envelope calculation, considering that in data centers, one of the most prominent pieces of software is databases. And if you look at the EU landscapes, data center landscape of the European Union, you will see that this calculation leads to a 7 megaton reduction, right? Now, again, I don't exactly know what 7 megatons is, but if you kind of create an image again, and again, I like the moon, so I will create an image with the moon. So if there was an hypothetical way to drive from the planet to the moon, you will go 20,000 times back and forth to achieve this 7 megaton savings, okay? So you go 20,000 times, and this is just the European Union, right? So now if you add the other continents, you will be basically multiplying this number by, I don't know, a factor of 5. So this is very large, and I think I take a lot of pride when I look at this kind of things, because my cool friends, they talk about sustainability, they work on all sorts of sustainability projects, and I'm the nerd in the room, and I say, okay, fine. But, in practice, I can actually be much more actionable than you guys, because if I do this, perhaps I'm optimizing something that my cool friends don't care very much about, but in practice, I'm having a much bigger impact than what they can have, right, by just talking about these topics, okay? So I take a lot of pride by being a technical person to do something like this, and I think we should all take some pride on that. All right, so I'm running a little bit out of time, so there are some other benchmarking data here. So this is Wikipedia, CH benchmark. You can look at that offline. But just wanted to mention a couple of interesting user studies. Most of our customers are under NDA, but some of them are nice enough with us that allow us to disclose some of this data. Airtel may be familiar in India. Other companies in different spaces, VMware. This use case is very interesting because we wanted to try DBTune on a different database management system, and specifically on a database management system which is NoSQL. And so we did that, and the performance improvement was 3 times better than what these engineers at VMware were expecting, right? And in the context of VMware, 34%, it's a big number because VMware, FoundationDB is a performance-first type of database management system. And so nobody really expects a 30% improvement on this type of things for FoundationDB. So that's actually really interesting. So there was an independent evaluation from our friends at Stormatics the other day. So they did this on their site. They tried DBTune. And I think it was very interesting because it's an independent evaluation, but also the results were interesting in the sense that if you run Postgres with the full configuration and then you use DBTune, you get on a benchmark that they were using, you get 13x performance improvement, which is massive. But also, if you're doing manual tuning, right? So they allocated a person that was doing this for a decent amount of time, and DBTune was still able to more than double the performance against the manual tuning baseline, which is, I think, a very good data point. I will invite you all to read the blog post. I think it's quite interesting and very well done by them. All right, so we've been part of the community for a little while, and we try to give back to the community as much as we can. One of the things that we do is to give the type of trainings that we gave yesterday here in this very room here. We've been doing this for a little while. We enjoy being part of the community. We don't talk only about DBTune. When we go, we talk about the problem space as well and try to sponsor these events as well in many occasions. And this is all I have for today. So if I have a couple of minutes, I could give a little demo. But in the meantime, we can also take some questions, perhaps.
Hello.
So I don't know how my internet is doing. I had many problems with. Okay, so it's all good. All right. So what you're seeing here is that the DB. There's a question. Okay, please go ahead.
So this is like a one-time tuning thing, or the DBTune controller needs to be running on the instance all the time?
Right. So ideally, you would like to have it always on. For now, we have a solution that you trigger it yourself. It does it for 3 hours in total, and then it shuts down. And then it will be up to you to re-trigger that tuning session again whenever you need it. Okay? But another model, which is a model we will want to have in the future, is to have an agent that is always on, but perhaps doesn't always tune because you may be uncomfortable with your system always changing behind the scenes, but something that is always on, that will be our V2 of the product. But today you go, you trigger it for 3 hours, it does the thing, and then it shuts down, and it automatically installs the new configuration as well.
Any overhead because of that?
Great question. So the overhead is extremely small. Everything happens in our server, and then there is a little bit of monitoring happening on the machine. And it's usually extremely small, talking about sub 1 or 2%.
But how do you can't go to like individual queries and things if you're monitoring from outside?
Sorry?
Can you observe individual queries and things?
No, we're focusing on parameter tuning for now.
Only parameter tuning. Yeah.
So the queries will be accelerated, but not because we're changing the queries. We are changing the infrastructure, basically, the queries run on, and then the queries become faster. In fact, we optimize for average query runtime very often. That's one of the objectives, and that it's a clear indication that the queries are going faster, but we're not changing the queries themselves.
Thanks.
Yeah, hi. Some of the parameters require a restart. So is there a manual mode where we say like, okay, apply the optimizations, things like that, or?
Right, so there are two types of parameters in Postgres. Some of them require restart, and some of them don't require restart. So depending on your application, you may not want the system to restart the database because this may be disruptive for your application. So some applications allow that and some applications don't allow that. So we give this option to the user. So the user can define, in this case, for example, you see there is this metadata here where the user here in this this was a tutorial in Cleveland with Postgres user group there. The user here was, which may have been myself or some of the DBTune folks, decided to set this flag to yes. So in this case, the database is being restarted. But it's really up to the user. You can choose not to restart it. So if you decide not to restart it, some of the parameters won't be tuned. And of course, the performance, some performance will be left on the table. But at the same time, there is still quite a lot of performance that you can achieve from the baseline, and then you basically won't achieve the top performance, basically, right? So we highly recommend, if you can, based on your application, to be restarting your database instance. It doesn't do it for a long time. It's for this window of like 2 to 3 hours, and so you need to get a little bit of small downtimes in this period of time. But then, of course, you rip off the benefits of the tuning, and the benefits may be very large. So you may want to do that. But it really depends on your application, right? So if you cannot restart, if you cannot do restarts, certainly no, don't do that.
Thanks. Actually, one more question. Like, approximately how many parameters currently you are able to tune?
Right. So yes. So I was going through the demo, and here you can see here the optimization target was throughput. You can go on query runtime as well, and this is the real-time view. So where you have your monitoring data, you can zoom in and see. You can see here the little restarts. There are little restarts here happening. You can see the white space there. And here is the tuning summary, which gives you basically how many times the configurations have been changed during this tuning process. So each dot is related to one configuration, and the triangle is the initial configuration. So if I click on the triangle here, you can see that these are the parameters of that configuration specifically. So a 4 megabyte for the work mem and 128 megabytes. So if you've been doing this for a little while, you will recognize that this is the full configuration of Postgres. And the number of parameters is shown here from this. So we have, in total, there are 12 parameters. One is not shown here, but it's a fixed change, so you can learn it from the user guide. But there are, let's say, 10 to 12 parameters being changed in total. And these are well-studied parameters from us, in a way that we do this tuning session in a safe manner, in a way that we will never crash your machine or something like that. So there's been a lot of work for us to select these parameters in a way that we're not just doing science, we're actually implementing a product that is safe to use even in production systems. And so it's true that we're only taking perhaps a fraction of the parameters that really matter for Postgres, but in practice, this set of parameters give you this 80-20 rule type of thing, so you already get most of the performance with this. And probably in the future, we will add a few more, but we will never try to optimize 300 parameters, because that wouldn't make sense. Those are not important.
So,
sorry, there's a question over there
okay.
On the bottom, yeah. Loud.
So does DBTune persist the changes that are made? Because if the server restarts, then those are essentially lost, right? The ones where reload is
changes. Sorry, if I understand correctly the question, the changes are so visualizable here. So if you find the best configuration, for example, over here, this is at 223 transactions per second. Now it will also change the work mem, for example, and the shared buffers. So this is a machine that has about 16 gigabytes of RAM. So this is basically allocating roughly half of that for shared buffers, which is the maximum that we allow. And for this very specific application, it's very convenient to have high shared buffers and smaller work mem. It's fine.
Yes.
Does that answer your question?
What happens at the end of the tuning session?
Huh?
What happens at the end of the tuning session? Does it persist?
At the end of the tuning session, the best configuration, which is this one, will be automatically installed on your machine. And if you are a database administrator, you will see this process happening in real time. This tuning session is completed. here, so you're not seeing any dynamic data, but this usually happens in real time in front of your eyes for 3 hours, and then it will stop and will install the best configuration that you found.
It needs permissions to write the config file, it means.
It changes the configuration file. That's the only thing that the system does. So the difference between a monitoring platform and this platform is that monitoring platforms are passive in the sense that just monitor your data. This is active in the sense that we change one thing in your system. But to be very clear, we only change this very one thing. If you remove the file that we added, you go back to normal. So it's a very minimalistic, intrusive action that we take on your system.
Thanks.
Hi. So
I think we're out of time, but I will take your question afterwards offline.
Yeah, it'll be quick. So during the day, the application gets data from the database when the clients are logged in. That is totally different set of SQLs. But during the night, there are heavier ETLs and jobs and other maintenance tasks that run. So how would DBTune adapt to this, and how would one affect the other?
Let's take this offline.
Okay.
Thank you.